Okay, this is problem number 16 in section 8.1 trigonometry. I've enlarged the picture for you. Let's just go over the wording so you understand what you're looking for here. Okay, they give you a line up here at the top, which is parallel to the ground. So we are going to use parallel theorems, parallel line theorems. You have a sports stadium here, a planetarium here. And ultimately what the question is to get the distance between them, but you're going to have to get that through multiple steps. They give you the distance that goes from the top parallel line down to the ground. It is a perpendicular line, so you will be able to draw a right angle and treat this problem as having two right triangles, one pointing off to the right, one pointing off to the left. So again, I've enlarged that picture for you. Our goal is to try and find this distance. Okay, here's the picture with everything in it. First thing I want to remind you of is this theorem right here. Given parallel lines, alternate interior angles are congruent. Okay, given parallel lines, and we do have a pair of parallel lines here, this line and this line. Alternate interior angles are congruent. Congruent meaning equal in measure. Okay, so what are alternate interior angles? If you don't remember this from your geometry class, alternate means on opposite side of this line that's considered to be the transversal. A transversal is a line that cuts into two parallel lines. So you have this line up here and the line down here that is parallel to the ground. This cuts into both of them. On one side of that transversal, you have a 40, and on the alternate side, in other words, the opposite side, that alternate's just another way of saying the other side. So this is above the transversal, and then this would be below. These are also called interior angles, which is why they're called alternate interior, because not only are they on alternate sides of the transversal, but they are both on the inside, sandwiched in between the two parallel lines. So if that's 40, this is 40, and you can either put the 40 inside here or outside, wherever it fits. Likewise, right here, you have the same thing playing into the problem on the other side. You have an angle that's on, now this time we're looking at this transversal, which cuts into top and the bottom parallel lines. So this is on one side. We'll use this as the alternate interior angle, and therefore it's 26. So by way of this geometry theorem, you are able to bring things that are on the outside of the triangle, just like we did in problem number 15. You had angles that exterior angles were on the outside, and they were part of a 180-degree angle, and so you were able to complete that 180 by subtraction. Here you're actually using a geometry theorem. Okay, so you're going to work on one triangle at a time. Remember, I would like to find this distance right here. So I think I'm going to find this first. That'll be a piece belonging to this right triangle. Then I'll find this next. That'll be one of the legs of the other right triangle. And then I'm going to add these together to find my final answer. So those will be my 3 steps in this multi-step problem. So x sub 1, let's see. If I'm standing on the only angle that I'm allowed to stand on, because you're never allowed to stand on the right angles, you have to stand on one of the acute angles. So if I'm standing here and I want to use this one leg that I do have, that would be opposite, and I would like to drag this into the problem so that if it's in my equation, I could actually solve for it. So opposite and adjacent, that's called tangent. So step 1, tangent of 40 is equal to opposite over adjacent. Here we are with the same issue that has happened many times in this section. What you're solving for down in the denominator, and it needs to be up in the numerator. This is in the numerator because you know tan of 40 is the same thing as tan of 40 over 1. Therefore, that's considered to be in the numerator. So you want to switch places. You want these to swap places. Let the x sub 1 go in place of tan 40 and tan 40. Tangent of 40 degrees will go down here, and now you're ready to enter it into the calculator. So now let's see. In this problem, they ask you to round to 2 decimal places. So I think while you're in the middle of the problem, you need to hold on to actually more decimals than that. Hold it out to the 4th decimal place for accuracy. And then you can round your final answer to 2 decimal places, because the more you round off when you're going through these successive steps, the further away from the final answer you're going to be. And my math lab is only going to be so lenient. Okay, so put that in the calculator. That would be 400 divided by tan of 40. Okay, so I got approximately 476, and I'm going to hold on to 7014. Excuse me. Part 2. I'm going to go into the other triangle, do the same thing. Tan of 26 is equal to 400 over x sub 2. In other words, opposite over adjacent. So tan of 26 don't forget to switch the x sub 2 with the tan of 26. So x sub 2 put that in the calculator, divided by tan of again, I'm going to hold that out to the 4th decimal place. So that would be 820.1215. And then when I go to get my final answer, which is what is the entire distance between here and here, I'll add these up and then I'll round it off to 2 decimal places. So x is going to be equal to the 476.7014 plus the 820.1215. And I get 1296.82 when I round it off to the hundredths place as they've asked. Okay, that completes number 16 and finishes section 8.1.